So we've got some momentum questions here that I'm going to go through the answers to. The picture shows luggage which has been loaded onto a conveyor belt. So we've got 3 pieces of luggage, all of different mass. So mass A 22, mass B is 12, and mass C is 15 kilograms. So what is the momentum of the luggage before the conveyor belt starts to move? Well, if it's not moving, it's got a speed of 0, and we know that momentum equals mass times velocity. So the momentum is mass times 0, so therefore the momentum is 0. And the reason? The objects are not moving, therefore they have no momentum. When the conveyor belt is switched on, the luggage moves with a constant speed. Which piece of luggage A, B or C has the most momentum? Now, given that they're on the same conveyor belt, you can assume they're moving at the same constant speed. So therefore, if the velocity is constant, it's going to only depend on the mass of the object. So the answer there will be A, because it has the largest mass. At one point, the conveyor belt turns left. The luggage on the belt continues to move at a constant speed. Does the momentum of the luggage change as it turns left with the conveyor belt? So momentum equals mass times velocity. Now, as a reminder, velocity is the posh word for speed because it also takes into account not just how fast you're going, but the direction as well. Therefore, momentum also has a direction factored in. So it's turning left, therefore it's changing direction. Yes. And the posh word to use is momentum is a vector. Direction matters. And draw a circle around the unit which can be used to measure momentum. Well, again, refer back to the equation. So we know that momentum is mass, measured in kilograms, times velocity, measured in meters per second. So get rid of the multiplication sign. So there are our units for momentum. The diagram shows a car being driven at 14 meters per second. The driver has forgotten to clear a thick layer of snow from the roof. Which of the following has the smallest momentum? Draw a circle around your answer. So given that they're all on the same car, so they're all moving at the same speed, the one with the smallest momentum will be the one with the smallest mass. Part B. Seeing an obstacle in the road, the driver applies the car brakes. The car slows down in a straight line. Does the momentum of the car increase, decrease, or stay the same? So if we're slowing down, that means our speed is going down. So the momentum is going to decrease. Part 2. As the car slows down, the snow starts to slide. In which direction will the snow slide? Backwards, forwards, or sideways? So if the car is slowing down, that's going to be travelling slower than what the snow will be travelling at. So the snow will go faster than the car and travel forwards. And another unit for momentum that you perhaps haven't seen yet is Newton seconds, and we'll cover that another time. The lorry, the car and the motorcycle are travelling along a straight road in the same direction as shown, and they're all travelling at the same speed. Which word is used to describe the speed of an object in a particular direction? So the posh word for speed, velocity. And which of these 3 vehicles have the greatest momentum? So at the same speed, you can assume that the lorry is the heaviest. So same speed, largest mass, momentum equals mass times velocity. So if they're the same speed, velocity won't make much difference. So because it's the largest mass, it will have the largest momentum. So for part C, complete the sentences. When a vehicle has a steady speed, the frictional forces... So if you're moving at a steady speed, they will equal each other because they are balanced. So they'll be the same size but in opposite directions. So friction always acts against you. So if you're going forwards, the friction will go backwards. And momentum has both a direction, which we've already mentioned, and a size, an amount, or the best word to use is magnitude.